You want a high pass filter. So we want a circuit with a cutoff frequency and a pass band right here in that range. So how do we build this circuit? Well, for one thing, we can use an RC circuit, just like previously, for the low pass. And the analysis will have the same kind of approach. At low frequency, 1 over the ZC will be 1 over omega C. At low frequency, ZC is high. So at low frequency, ZC is a lot greater than V out. A lot greater than R. Okay? If we think of the circuit like this, V in, V out, ZC is a lot greater than R, so V in, most of the V in drop, apologize again, most of the V in drop will occur across ZC, and very little of the voltage drop will occur across R. So therefore, at low frequency, we have the attenuation occurring, which is evident right there. At high frequency, ZC equals omega C. This is high, and since this is in the denominator, this is low. Therefore, R is much greater than ZC. Therefore, the majority of the voltage drop will occur across R, being in the passband range. And it's important to note that this filter, along with the low pass filter, is essentially just a voltage divider. So your output is never going to be higher than your input. There's no amplification going on. To do that, you need to add an op amp. Now, let's look at this way. I'm drawing a low pass filter. V in, V out, R and C, okay? If we have the voltage go high. Now we know in a capacitor, IC equals C dV dt. The VC equals something like 1 over C integral of I dt or something like that, plus something. Basically, the voltage can change in 0 time across a capacitor. The current can change, but the voltage can. So if this is V in, or V out ends up being spike down, spike down, spike up, spike down. This is V out. And you can see when the rate of change, any rate of change occurs, and this is essentially a really fast edge, we have a spike. Therefore, high pass is differentiator. Okay? So if we want to make this an op amp form, it's going to look like this. And it's going to have the same passband equations as the low pass filter, except it's going to be a high pass. Now, in this situation, this being an inverting op amp, your AV is R2 over R1, so it's going to, your output can definitely be amplified. Now, just a side note, can also do this with a, this is actually FC is equal 1 over 2 pi R1C. Okay, it's the R1, that's your low pass combination. Now, high pass combination. Now, if we're going to do the low pass, the op amp would look like this. R2, C, R1, V out, V in, okay? And your cutoff frequency would be 1 over 2 pi R2C. Got it? Thanks.